All right, we're back. We left off on number 14. Hopefully you guys can see that. It's not too far away. I can try to zoom in a little bit. Hopefully that helps. All right, on number 14, we are left with an isosceles trapezoid. All right, so this technically isn't a parallelogram. Trapezoids are not parallelograms. But they have interesting characteristics. One of the staples of isosceles trapezoids, and really any trapezoid, is that consecutive angles are supplementary. You're talking about a pair of parallel lines, so you have to have angles that add up to 180 degrees. So this angle right here and this angle here are considered consecutive. They're considered consecutive angles from the parallel lines here. So it's kind of like we had consecutive interior angle theorem. That's where it's showing up. So 6x plus 20 plus 4x, these two added together, they have to add up to 180. So nothing really new about solving equations. Take away the 20 here. 6x plus 4x is 10x. 160, divide by 10, divide by 10. X equals to 16. So I'd put x equals 16 over there, but again, I'm not going to mess with the document right now. Just you put it over there when you're writing out these notes. And then what we need to do is figure out what to make of this y value here. Now, I don't know if you guys remember this, but the base angles of a trapezoid are congruent. And technically, you could classify these as base angles or these as base angles, because I could flip the trapezoid and talk to you about it like this. I could say, hey, you see this trapezoid here? Look at this base right here. These are the base angles. It doesn't matter which one you talk about. So this y degree measure is equal to, it's congruent to 6x plus 20. Because the base angles are congruent. We know what x is. It's 16. Then you take 6 times 16, which is 96. Add 20, and you've got 116 degrees. So x was 16, y equals 160 degrees. 16 degrees. Number 15. Okay. So we know we have a parallelogram because the opposite sides are given to us as congruent. That's kind of one of those, if you've got that, you know you have a parallelogram. Well, here's one thing we haven't talked too much about. Perpendicular bisectors, or not perpendicular bisectors, but diagonal bisectors is a true characteristic of parallelograms. So it means that these diagonals cross each other. That means that 3x plus 4 is equal to 2y. That's just how parallelograms and their diagonals work. 3x plus 4 is equal to 2y. And 2x plus 7 must be equal to 7x minus 3. So these two equations, you should be able to solve for both x and y. I would start with the second equation because there's nothing but x's there. So 10 is equal to 5x. Divide by 5, divide by 5. You got 2 equals x. And the x there that was solved from this equation is the same x right here. This is, therefore, 2. And now we can solve for y. So this would be 6 plus 4 is equal to 2y. 10 equals 2y. Divide by 2. y equals 5. Over here, we've got a rectangle. They don't say that this is 90 degrees, but if this whole thing adds up to 360, you can take 360 minus 90, 90, 90, and you'll get to 90 for that one. Now, this says that BD is 8y minus 4. AC is 7y plus 3. We just talked about earlier how the diagonals of rectangles are congruent. The diagonals of rectangles are congruent, which means we set them equal to each other to find the missing variable. So that one's pretty basic. Not a lot of fanfare for this one. Get y by itself. And you got 1y is equal to 7. On number 17, we've got a kite, which means, again, 1 and 2, those two angles have to be identical. They're the same measure. So if we called them, I don't know, just angle x, then you say x plus x, which is 2x, adding along 110 and 48, those all have to add up to, well, 360 degrees, because every quadrilateral has interior angles that add up to 360 degrees. So that leaves us with, we got to combine like terms on the left. That's 158. Take away 158 from both sides. Think about it like you're taking away 160 from 360, which would give you 200. Except you didn't take away 160. You took away 2 less than 160. So instead of 200, it's 202. Feel free to use a calculator as well. Divide both sides by 2, and x is equal to 101, which means angle 1 is 101 degrees, and angle 2 is 101 degrees. Remember, it's always important to answer the question that is asked of you. All right, on 18 through 20, all we're given is a diagram of a quadrilateral, and they're asking us to say whether or not it for sure is a quadrilateral, it is for sure a parallelogram or not. So this one has 2 pairs of opposite angles that are congruent. Yes or no? Is this a parallelogram? Because 2 pairs of opposite angles are congruent. The answer? Yes. It is a parallelogram. That's one of the kind of the staple definitions for it. What if we have 1 pair of opposite sides are parallel and 1 pair are congruent? And that's all that's really given to us in this diagram. Is that a parallelogram for sure? No. Although the way I drew this, it makes it look very similar to a parallelogram, doesn't it? I don't like this one right now. It's messing with me. But the answer should be no, because it didn't give us more information to make a solid conclusion. This last one is a perfect example of diagonals that bisect each other. They cut the diagonals into 2 equal parts, each of them. And that is, again, a big characteristic of parallelograms. All right, I'm going to skip example 21 because I didn't put that one on the actual homework that you've got, and I think at this point, let's just cover the meat and potatoes of what you need to know to complete this assignment. All right, so this last part is just all about saying which of these 1, 2, 3, 4, 5, 6, 7 quadrilaterals fit the description that's given to you. Okay? So, I'm going to try to roll through this relatively quick. Opposite sides are congruent. That for sure is parallelogram all the way. And if it's parallelogram, then the rhombus, the rectangle, and the square all follow suit. Because rhombuses, rectangles, and squares are parallelograms. So you would say, yeah, parallelogram, rhombus, rectangle, and square. So that's letter A. Letter B, only one pair of opposite sides is congruent. Only one pair. So that takes away all of these. The question is, which ones have only one pair of opposite sides that are congruent? Well, that's not kites. Kites have to have consecutive sides congruent. Trapezoid, I mean, that's a trapezoid where none of the sides are congruent. But an isosceles trapezoid always has to have opposite sides congruent. One pair. So the last one is just isosceles trapezoid. All the opposite sides are parallel for C. That's a hallmark of all parallelograms. So you would say parallelogram, rhombus, rectangle, and square. If it's only one pair of opposite sides parallel, that's what a trapezoid would be listed under. So a trapezoid has one pair of opposite sides parallel, but an isosceles trapezoid is a trapezoid. So anything that works for the trapezoid has to be also listed for an isosceles trapezoid. All sides are congruent. Let's see. All the sides are congruent. You had opposite sides that were congruent for parallelograms. We have to think rhombuses, all right, or rhombi, those have 4 congruent sides. And a square is a type of rhombus. Nope. I think we got them all. Opposite angles are congruent. That's a definition of a parallelogram. So you'd put the parallelogram with all of its others, rhombus, rectangle, square. Only one pair of opposite angles is congruent. That's the kite, remember? These two. Let me scroll down here. So that's A through G. All right, all angles are right angles. That would be a rectangle and a square. All consecutive angles are supplementary. That would be all parallelograms, which means you keep the rhombus in there, you keep the rectangle in there, you keep the square in there. The diagonals bisect each other. Same. Only one diagonal bisects the other. That's a kite. The diagonals are congruent. We talked about that earlier. It was a isosceles trapezoid, a rectangle, and then a square. And then the diagonals are perpendicular. That would be all rhombuses, kites, and squares.